So it's just another way to measure angles. Angles, not angels. That lasted less than 30 seconds. Yeah. There we go. Again, like angles are like user friendly. That's why we've used them up until now. It's easy to be like, hey, that's 90-degree angle, and it's really nice and friendly to work with. Radians are not friendly to work with. The values are crazy, but they are good for math purposes, which is why they start to become relevant around like your university math, which is what you guys are getting ready for. 1 radian, it'll pop right back up, is the exact amount that you need to open or have like an angle so that the radius and the arc length are the exact same. So if you look at that picture that you have, these 3 lengths are all identical. So that's 1 radius right there. Right, that's the radius. This is the radius here. And this is your arc length. Right? It's like the distance around the curve from this point to this point. If you have that scenario where you have that like perfect opening so that those 3 things are all the same length, this is exactly 1 radian. As an angle, it's like 57.3 degrees. So radians are going to be very weird compared to angles, and they're not nearly as nice to talk about. We're going to have a lot of like 1.73 or random decimals or the value pi. We're going to have lots of that stuff when it comes to radians. Cool. That's like the actual definition of what a radian is. Not that I think it's really that important, but it's good to know like why it exists, I guess. Let's calculate. So we're going to take radians degrees and we're going to switch back and forth. Perfect. To be able to do this, we're going to look at a circle, and there's going to be a couple points that we know on a circle that are important. So if you start at the middle of the circle and you went straight over to the right, we're going to call that 0 degrees. Perfect. That means if I went from here to there, how many degrees would that be? That'd be 180 degrees. Perfect. 180 degrees equals exactly pi radians. If you did a full circle, so you started here and you went all the way around, how many degrees would that be? Yeah, that would be 360 degrees. Or 2 times 180, right? 180, another 180 would be 360. In radians, how much would a full circle be? It would be 2 pi radians. Exactly. All right, since 1 pi got you halfway, 2 pi gets you all the way around. Cool. To be able to convert between degrees and radians, we need to use this information right here, which is that 360 degrees equals 2 pi. And we're going to use that information to help us calculate radian measurements. That says 360 degrees equals 2 pi. There we go. What we're going to do is we're going to set up something called equivalent fractions. My equivalent fractions aren't actually going to be the same as what they have here. So you can give that the old cross out. What we're going to set up is we're going to make two equivalent fractions. The bottom of the fractions will be 360 degrees. Actually, it'd be, give me 1 second, let's do 180. I do like that, actually. I do like that they have 180 there. Equals pi. Normally I do 360 equals 2 pi, but it's actually nicer with 180 equals pi. I'm going to put it on the bottom. Okay, the one on the left has it on the top. I think that just makes it harder. Every one of my fractions is going to start like that because I know that 180 degrees equals pi degrees. I know that's true. On the top of your fraction, we'll go degrees on the degree side. So this would be my degree side. And radians on the radian side. So this would be my radian measurement. The first question says, convert 40 degrees into radians. That means I know my degree side. I don't know my radian side. So I have 40 degrees divided by 180 degrees equals x divided by pi radians. Anytime you're converting radians into degrees, that's how you set it up. We're going to do a whole bunch of examples together. I know, because we've done this many times, usually the first 2 times seem insane. And then you're going to realize it's the exact same fraction every single time, and it's really not hard. Perfect. Degrees over here, radians over here. Our goal is to solve for how many radians it is. So we need to get x by itself. If I wanted to get x by itself, I would multiply pi to the other side. So I'm going to multiply both sides by pi. That gives me on the left-hand side 40 pi over 180 equals x. That means 40 times pi divided by 180 would equal the number of radians that it is for 40 degrees. You can reduce that fraction. So we almost always leave our answers for radians in exact values, meaning you need to simplify this. So 40 and 180, if you put 40 divided by 180 in your calculator and then you math frac it, it should simplify it for you. And it's going to be 2 over 9. Or you could divide both these by 20 if you're doing it by hand. My radian measurement is 2 pi over 9. So if you said, how many radians is 40 degrees? The exact value would be 2 pi over 9 radians.
We always keep the pi in a...
If they want exact value, yes, you just leave it as pi. They will usually want an exact value. If they ask you for a decimal, which it does say approximate value, that means decimal, then you put in your calculator. So 2 times pi divided by 9. Your pi button, I'm going to try to use my calculator on my computer because that'll probably break it. Your pi button is right here, right? Second, and then your exponent button. So 2 times pi divided by 9 would be 0.698 radians. Normally, I would only round to the nearest hundredth, but Merrick's in the room. I can't even talk about timelines with this guy around.
Wait, is that always unit of measure?
The unit of measure will be radians. And honestly, like they don't even put radians very often. They just put like 2 pi over 9. And you would know that's in radians. Awesome. Let's convert a bunch. So we're going to convert 5 pi over 6 into degrees using a diagram. I'm actually going to do it by hand first, so using algebra like what we just did. Then I'll show you how you could do this with a picture. Okay. Convert this into degrees. Always start with the fraction. 180 equals pi. Always starting like that. Degrees go with degrees, radians go with radians. They told me that I have 5 pi over 6. So that is my radian measurement up here. I have 5 pi over 6 divided by pi. I don't know the degrees, so that's what I call x. And there's my setup. X over 180 equals 5 pi over 6 divided by pi. Cool. To simplify this, you're going to have to multiply that 180 over. It gets messy because you got like pi divided by pi over there, right? Which is not the most fun. It looks a lot uglier than it is. So if you had 5 pi over 6 and I divided it by pi, it actually works out very nice. It just looks bad when I have it as a fraction over a fraction. The reason it works out nice is because that's really pi divided by 1. Agreed? When you're dividing fractions, we do something called kiss and flip. And it turns into 5 pi over 6 times 1 over pi. And these pi's actually end up canceling out. So anytime you get that pi on the top of the fraction and you're dividing by pi, the pi's will just cancel out. So it's the same thing as saying 5 over 6. That's why it looks bad, but it's really not that bad. So I have x over 180 equals 5 over 6. Looks uglier than it is. Multiply that 180 to the other side. And you get x equals, oh, I don't like that. Get rid of that equal sign. There we go. 150 degrees. That is how you would algebraically solve this. We're going to do a lot of diagrams, and you're going to have something called a unit circle, which if you know anyone from last semester, they probably made them all the time. This is kind of a good intro to the start of what unit circle is. So let's look at our diagram. And we're going to start off with like our basic knowledge of a circle, which is that if I went straight to the right, we're going to call that 0 degrees. And if I went straight left, that would be a 180 degree opening. Agreed? Okay. We're going to break that top segment up a little bit. So this is 180 degrees. I'm going to cut it in half. So if I cut it in half here, what would that angle measurement be if I went straight up?
90.
It'd be 90. How did you know it was 90?
Because 180 divided by 2 is 90.
Yeah, because it was 180, but I cut it in half. Right? 180 divided by 2. This is 180 degrees divided by 2. Or 90. Awesome. What does 180 look like if we're talking about radians? 180 is 1 pi. So then what do you think 90 degrees is in radians? It's half a pi. Right? If this is pi radians, then this is pi over 2 radians. Cut in half. Okay, let's divide this up into fourths. So if I divided this into fourths and I took that top piece, it would look like this. One, two, three, 4 pieces. Awesome. If I said, what's the degree measurement right here? It would be 180 divided by 4 because I broke it into 4 pieces. What would this be in radians then? It would be pi over 4. Right? And we wouldn't call it 180 divided by 4. You could actually calculate 180 divided by 4, and it would be 45 degrees.
Why did we learn this about unit circles like any time earlier when we were doing it? Because this makes so much sense. This makes more sense than how she showed us last semester. And it was so
Yeah, it's also the beginning. Don't worry, it'll get harder.
Wait till we have to memorize.
Okay, so looking at this, this is 180 over 4, right? This would be 2 180 over 4s. 180 over 4, 180 over 4, that'd be 2 180 over 4s, which is 180 over 2, right? The same thing, 45 plus 45 would be 90. So that's kind of how those two things relate to each other. Yeah?
Do you have to put like 180 over 2?
No, I'm doing that so it's easy for you to visualize the radians. Because if I put 90 instead of 180 over 2, then you would be like, where'd the pi over 2 come from? And I'm just trying to show that connection of this is just that cut in half. That's why it's pi over 2. This one's going to be a little trickier. So if we think about this purple one, this purple one, you gotta look where I'm pointing. This would be pi over 4. This would be another pi over 4, so now we're at 2 pi over 4s. That means to here would be 3 pi over 4s. So this section out here is 3 pi over 4. If you talked about it in degrees, that would be 45 degrees plus another 45 degrees is 90, plus another 45 degrees is 135. So if you wanted to talk degrees, you still could.
I'm just going to ask you, why are you showing this?
Yeah, like the chopping it up. Okay, I'm going to do one more so that you can see visually how we know what 150 degrees is. We're going to take that top piece and we're going to break it into sixths. So 6 pieces. I'll use green. Hopefully that stands out. So if I was to divide it into sixths, it would be a line here, a line here, a line straight up. So this would be 1/6, 2/6, 3/6, which is why I know I'm at half. Then I would have 4/6, and then 5/6. It's a hard word to say. And this would be 6/6 if I went straight over, which is just pi. Six.
Take away the purple ones. That doesn't make sense.
Oh,
It's sixths.
okay, you don't count the.
You don't count the in between the purple and green.
Yeah, the purple one is not part of that, right? So the purple one is fourths. That would not be one of my sixths. So if I get rid of the purple so you can visually see it, 1, 2, 3/6, 4, 5, 6/6. If you were to then write those as radian measurements, this one would be 1 pi over 6. Right? I chopped up into 1 pi is the whole way. This is 1/6 of the top. This would be 2/6 of the top, right? When I go to the next line over. So 2 pi over 6. Yeah, so that one would be pi over 3 if you simplified it, which we will in the future. If you went straight up, that would be 3 pi over 6, which is just pi over 2. This one over here would be 4 pi over 6. And then I get 5 pi over 6, which is what our question was talking about. In radians, 5 pi over 6 would get me from here to here. That's the opening that we're talking about. If you wanted to talk about it in degrees, you would go 180, break 180 into sixths, which is 30 degrees. You would go 30, 60, 90, 120, 150 degrees. Which is like how you visually can see that 150 degrees is equal to 5 pi over 6.
So sometimes you don't even need to use maths. You could draw it.
We'll use our diagram a lot, yeah. And we're going to do something like this, and we're going to do it all the way around, and we're going to chop it into sixths, fourths, thirds, and halves. So you're going to have a lot of lines on that circle, and knowing where each line actually connects to, and then there's going to be points and degrees and radians. It gets pretty big.
A lot more space.
A lot more space, yeah. Yeah.
So are you counting the spaces or the lines?
So it's the line. So if you were to measure this, like, zoom here, imagine you started here and you're like opening it like an angle. This would be 1 pi over 6. This would be open 2 pi over 6s, 3 pi over 6s, 4 pi over 6s, 5 pi over 6s. And that's the angle I've created. Which would be equivalent to 150 degrees.
Can I just get like the unit circle sheet thing where you can just look at it?
Yeah, like when we get to it, which we won't do it today, I think tomorrow, I'll give you a blank copy of a unit circle. It'll take up a whole page. And there's a lot to it. So you'll have lots of space to do it.
Is it on like the key, like or the
That's a good question.
formula sheet?
The unit circle is not on your formula sheet. You will need the unit circle for your formula sheet. Like you'll need to be able to make one.
So is that normally like one of the first things you do?
Yeah, if you ever watched like a Math 30-1 test, which why would you ever watch Math 30-1 test? But the English teachers do it all the time. And they're always amazed to watch because literally the test will start and every single person, well, they supervise you guys, right? So like Math 30-1 test, every person will do the same thing at the very beginning. You will pull out a blank piece of paper, you will draw a unit circle. That'll be the first thing that everybody does. And then the English teachers are like, they're like robots. It's because you need it. So you will need the unit circle. It's not that hard to make. So don't stress about making it. There's lots of easy tricks that'll make it nice and like, you made one, right? Last semester. It's not terrible, right? It's easy. It looks bad. It's not.
Well, there's tricks. Isn't everything across from each other?
Yeah, it's honestly, there's lots of patterns and tricks to it. So drawing, it's not hard. Using it is the trick, which is why I'm spending like so much time right now trying to show you how it actually chunks out. Because I think that if you can understand that, you can do the unit circle anywhere. Okay. We're going to convert the following to radians. We're going to do it all algebraically because that's much, much, much easier. So convert the following to radian measurements. We're looking for radians. Every single calculation is going to start as a fraction equals a fraction. The bottom will always be 180 equals pi because we know that 180 degrees equals pi radians. On the top of your fraction, whatever you're looking for, you call x. So I'm looking for radians. That goes on the radian side. I know my degrees. That goes on the degree side. I have 30 degrees over 180 degrees equals x over pi. You then have to solve that. You're going to multiply pi to the other side. The pi's will cancel out. You're also going to simplify 30 over 180. So if you throw in your calculator 30 divided by 180 and then go math and then frac, you should get 1 over 6. So this becomes 1 pi over 6 equals x. The radian measurement is pi over 6. Visually, that means you took pi and you divided it into a sixth. That looks better now, right? Third time we've done it, and it's like, okay, I think I see. Perfect. I see people are working ahead. So work ahead on the next 6. I'll put the answer up so you can see if you're right or wrong. Okay, so you should have all those up there. I showed you the first step and then the final answer. I didn't show all the multiplication and crossing out, but all I'm doing is I'm multiplying pi to the other side, and I'm reducing that fraction. So in your calculator, you can do it. Like 225 divided by 180, math frac is 5 over 4, so it's 5 pi over 4. Yep. Visually, you could find these things. What this means is that you took your top circle and you cut it into fourths. So 1/4, 2/4, 3/4, 4/4. This is 1/4, which in degrees would be 45 degrees. Because it's 45, 90, and then 180 would be all the way around. And like that is what we're doing when we're talking about radian measurements on these diagrams. This one means you have 5/4 around the circle. So if you started it off as a circle and you cut it into fourths, that'd be 1/4, 2/4, 3/4, 4/4, 5 pi over 4 would be over there. Right? Like visually, there's 1/4, there's a second fourth, there's a third fourth, there's a fourth fourth, there's 5/4. That's what we're doing. We're taking it and we're chunking it out into fractions. That'll hopefully help when we get to tomorrow's stuff. Okay. Other way around. So you got 6 examples here. I'll do 1 to start, and then I'm going to let you try the next 5. So we're going to convert radians into degrees. I'm going to start with B. These should be better numbers because we've actually seen a lot of these. So I want to convert that into degrees. I'm going to sneeze. Thank you. So I always start with a fraction equals a fraction. Always start with 180 equals pi. In the denominators. Then we make the numerators equal. I don't know what the degrees are, so I call that x. I do know what my radian is. It's pi over 2. A fraction divided by pi looks scary. It's not. Those pi's will cancel out, meaning I have x over 180 equals 1 over 2. Right? Pi divided by pi is 1. That's why it's 1 over 2. Multiply 180 to the other side. And I have x equals 90 degrees. So pi over 2 is equivalent to 90 degrees. Go ahead and try the next 5. Up there. You will need that ability to convert. Okay, if you took math last semester, you might have just known those answers because they all are part of the unit circle, right? They're divided by 4s, 3s, and 6s, which is why you might have just known those answers. There will be questions where it's like convert 27 degrees into radians. Unit circle doesn't know how to do that, right? So you do have to be able to convert this way. We just use very nice examples that work out to whole numbers.
Wait, and
Awesome.
if you're calculating a degree, how many decimal places will you go to?
Well, it will say degrees are typically rounded to the whole degree. So you go up or down to the whole thing, no decimals, typically speaking. But it will tell you. Cool. Flashback to math 20-1. When you talk about negative degrees, remember that just means that you're going the other direction. So when we were talking about all of our stuff before, notice that I was going this way. That's the positive way to go, counterclockwise. So negative 420 means I went the other direction, 420 degrees. And positive is counterclockwise. Negative is clockwise. That's flashback math 20-1. It's just been a while, so I might as well talk about what a negative degree means. Awesome. Arc length. This is something new to you. Arc length is like the distance around the outside of a circle to get from one point to another point. You will... Good question. Well, you have that. The formula that's on your formula sheet is actually A over R equals 80. Is that right? Okay, so it nicely tells you what each letter means. So A is the arc length. That means distance along the curve or the arc, right? That's why it's called arc length. R stands for radius. Radius would be from the middle to the edge. And then theta is the angle, but in radians. Okay, you have to be in radians. There's no doing in degrees. Perfect. This will help us do some calculations. So let's try this one. It says the arc of a circle is 10.4 centimeters long and is created by two radii with an angle of 287 degrees at the center of the circle. Calculate the radius of the circle to the nearest tenth of a centimeter. Okay, let's draw what they said. So they said the arc of a circle. They've drawn a circle for you already. That's nice of them. Is 10.4 centimeters long. That means if you were to go along the edge of a circle, they want you to go 10.4 centimeters. Is created by two, I think that's radii, but two radiuses, but radiuses is not a word, so that must be radii. Yeah, radii. I like it. With an angle of 287 degrees. So, somewhere in here, you have two radii. They create an angle of 287. You could draw that anywhere that you want. So if I draw one right there, I then need to go approximately 287 degrees. I'm going to guess that 287 degrees is somewhere like there. There's my radii, R and R. There's my angle on the outside. They gave me one other piece of information. That was the arc length, which was created by going around the outside. And they told us that that distance was 10.4. Awesome. Notice that I didn't do in here. Okay, those are both arc lengths. This orange distance is an arc length, but that would be related to this angle on the inside, which they never were talking about. They were talking about the angle 287, which created this arc length. That's why we're talking about that purple arc length. Try to erase it without erasing everything. Are we okay with my diagram? Feeling good? All right, calculate the radius of the circle. So you're trying to solve R. Perfect. We know the formula A equals R theta. Actually, no, let's start with the one that'll be on your formula sheet. It's harder to work with, but that's okay. The formula sheet gives you this one, A over R equals theta. Let's do that one because it's actually harder, but that's what's on your formula sheet, so that's what you would probably do. Perfect. To use that formula, you need to know the arc length. We do know the arc length. The arc length is A equals 10.4. To use that formula, you need to know theta. We do know theta. Theta is 287 degrees. That's a problem, isn't it? Why is it a problem? Our formula has to be in radians. Has to be, right? Like that's what the formula is based off of, radians. So you're going to have to convert that. To convert it, you start with 180 equals pi on the denominator. You then put what you know on the top. So I know we have 287 degrees. I want to know the radians. I'm going to call that x. To calculate that, I multiply pi to the other side. This is one of those scenarios where we will just use a rounded value because it's like 287 divided by 180 is not going to work very nicely. Plus, our answer in the question will be rounded to the nearest decimal. So it's okay to round, but use as many decimal places as you can. Okay, so when you calculate this, 287 times pi divided by 180 gives me 5.00909 equals x. If you round that, it might cause you to like double round, right? So try to use as many decimals as you can. If you're willing to even go beyond that, then you should. 5 should be safe. But yeah, and if you know how to like save things as x, you can do that, or you just type the whole thing in your calculator too, which is what I would do. Perfect. Let's go back to here. Let's not use this one because that's wrong. That's in degrees. We want radians. 5.00909. Now we can do this formula. Fill in everything you know. So I got 10.4 divided by r, which we don't know, equals, actually I'm going to call it r, sorry, equals 5.00909. Okay, if you want to solve that, we got to do a little bit like cross multiplication. So typically what people end up doing is they divide by 10.4, which is incorrect. If you divided by 10.4, that would tell you what 1 over r would equal. You don't want to know what 1 over r is. You want to know what r is. So when you're solving for something on the bottom of a fraction, you have to multiply that thing to the other side. So I need to multiply r to the other side to get it off the bottom of the fraction. And then divide both sides by 5.00909. So that you get this calculation. 10.4 over 5.00909 equals r, your radius. It's been a while since we've solved fractions where things are on the bottom. Please just remember you've got to get it off the bottom. So you move it to the other side and then divide the number to the other side.
I think just rearrange that fraction for the
Those of you who are in physics, you physics people would probably do that. Yeah. So if you want to rearrange the formula with letters before the numbers, feel free. Go at it. Who would have thunk it, hey? It asks us to round to the nearest tenth of a centimeter. Your answer should be 2.1. That means the radii are 2.1 centimeters long. Yep.
How do you feel about units?
I hate them.
Like, but like when you dock marks of units, you guys want to put it?
Would I dock marks? No. Will they dock marks? Better question. I'll look into that. I do not believe that units would be marked.
Well, isn't it
You should say centimeters. So like I should say 2.1 centimeters. There is written response. Yeah. I don't think they would dock you marks if you did not put centimeters. In my experience, they do not, but that is all -2 experience. -1's a lot pickier. All right. Last page. Okay. You try all three. Remember your arc length formula has to be in radians. Give it a shot, right? It is practice for you. I'll put the answers up on the board so you can check your work. But just try your best on your own first. Take a couple more minutes just to finish up. The answers are up there. Yeah, just keep working your way through. Ask questions if you get stuck.